Hey guys, welcome to Successive Differentiation class in Rave Class. So from till episode 6 we have studied trigonometric functions which involved product rules as well as log functions. So in this particular class we'll study inverse trigonometric functions in successive differentiation. So let me start from a simple problem. So this is a given problem. So if y is equal to sine inverse of x, then we have to prove that 1 minus x squared into y2 minus xy1 is equal to 0, where y2 is the second differential and y1 is first differential. So from this particular problem we can say that we have to find the second differential equation. So the solution follows the same steps. So first consider the given equation, that is y is equal to sine inverse of x. I call it to be equation 1. So from this episode onwards I'll be going quite faster so that we have a lots of portions to get completed. So y is equal to sine inverse of which is the inverse trigonometric function given over here. So the main thing we have to know here is, remember this particular result. So the differential of sine inverse of x is 1 by root of 1 minus x squared. So this is the result that you have to remember. So this result is quite helpful over here in this particular problem. Similarly, cos inverse of x gives you a negative sign over here. So I don't think I have to mention it in next coming classes. So let's proceed with solving this problem. So y is equal to sine inverse of x. So differentiate 1 with respect to x. So you get the first differential, that is y dash, to be 1 divided by root of 1 minus x squared. So this implies, so what I'll do it now is that I'll take the denominator function towards the left hand side of the equation, which gives me the root of 1 minus x square into y dash, or here y dash I consider to be y1, so please note that. So y1 is nothing but the first differential, is equal to 1. So call this particular equation to be equation 2. So this particular function now follows with second differential equation, where we differentiate this equation 2 in order to obtain the given proving function. So this is the result that we have to show here. So differentiate equation 2 again with respect to x. So we get, before that there's a slight modification that has to be done. You have to just square equation 2. So what is the necessary to square is that you can get rid of this root over here. So if you square, you get 1 minus x square into y1 square. So y1 is the first differential, I repeat again, so 1 square is nothing but 1. So I'll differentiate the equation 2. So this is the equation 2 with the square one. So if I differentiate, I have to follow the product rule. So you know that what is the product rule. So I'll just write directly the result. So that is nothing but 1 minus x square into differential of this is 2y1. So again differential of y1 is y2. So that is nothing but the second differential, minus y1 square as it is, and differential of minus x square is minus 2x. So this is plus. So now what will be the final answer? So the final answer will be, after solving this particular function, so you can see one thing over here. So there is two expressions. So this is the first expression and this is the second expression. So these two are summed. So you can see that y1 is common over here, and so differential of 1 is 0. So the RHS is 0. So I can divide this entire equation by y1, thus resulting in the prove that function. So if I divide by y1, 2y1, so this particular equation will remain only xy1, and here 2y1 will be lost. So you get 1 minus x square y2 plus x. So hence you got the final result over here, that is nothing but 1 minus x square y2 plus x y1. So that was the thing that has to be proved here. So to prove that thing, it's given over here. So we have proved according to the given equation. So now let's see another cos inverse function and then a follow-up edition or episode. So stay tuned with Rave Class.